Hello, my name is Evan Carbino.
My name is Lydia Walsh.
We're here to talk about the effects of removing burning bush. Burning bush is an invasive species of plants. They originated from Asia but were brought over to the United States in the 1860s as a decorative houseplant due to their beautiful red color when fully grown. However, they quickly spread into the wild, overtaking many of the native plant life. Here at Westfield, in 2021, a group of students went down to our university's test area, which is a small island, and removed as much burning bush as they could find. This year, for our project, we went back to that same area to do our testing to see if their work had paid off. Needless to say, when we got there, we noticed that much of it had actually grown back, despite their best efforts. We hypothesized that by removing the burning bush, it will have a positive effect on the native plant species found in the test area. Some of these impacts could include a large DBH in trees and an increase in their biomass, since burning bush deprives native plants of their sunlight, water, and nutrients. Removing it should logically allow the trees to develop more biomass.
So for our methods, we measured the biomass and diameter growth of trees, and we collected data from the area where the removal took place, which we called the restored area, and the area where it was not removed, which we called the degraded area. And to measure the diameter growth, we used what are called dendrobands, which are these black bands that are wrapped around the width of the tree, and in the middle there's a folded piece of fabric, and there's a line that indicates how much the tree has grown. And to measure the growth, we basically measure the distance between the folded piece of fabric and the line. And to measure the biomass, we would collect leaves from leaf litter boxes, and these boxes were placed under the trees as well as the dendrobands by Amber Stearns, who did her senior honors project on the same subject last year. And after we collected the leaves from the leaf litter boxes, we would put them in a drying oven for about a day. And once they were dry, we'd weigh them, and that is how we got the total biomass for both of the areas. And these are just some pictures of the restored and degraded areas. As you can see, the degraded area has a lot more burning bush than the restored area, but the restored area still has some burning bush.
Our results actually really surprised us because the degraded area actually had slightly more tree growth than the restored area. The average growth was about 0.49 centimeters for the restored area, while the degraded area had an average growth of 0.55 centimeters. The mean diameter of the trees was also higher in the degraded area than it was in the restored area.
So the total biomass in the restored area was 248.94 grams. It was 228.03 in the degraded area. It's also very important to mention that one of the boxes in the degraded area was lost, which impacted our ability to get an accurate sample. And the average leaf litter in the degraded area per box was about 22 grams. So assuming that lost box had an average amount of leaf litter, the total leaf litter for each of the areas would have been very similar. And the tree growth was better in the degraded area than in the restored area, which surprised us as it went against our hypothesis. And we did t-tests for the leaf litter and tree growth, and each of them suggested that the differences weren't significant, so we could not come to any conclusions with our data. Therefore, the effects of moving burning bush, remain unclear. And as I said earlier, it's important to mention that the restored area still had a lot of burning bush just by having less than the degraded area, which could impact our results. It's possible that if the removal had been more successful, the results would have been different. And overall, more research should be done to get better results about this subject.